In this next part, we're going to look at the precision and uncertainty of the numbers. So we've got 310,000 plus or minus 20,000, which means then the upper limit would be 330,000 and the lower limit would be 290,000. So the upper limit of the weight would be 330,000 and the lower limit would be 290,000. I wrote 333 and it should be 330,000, 290,000. Now, the next one is the conversions of the mass. The mass we already figured out was 1.4 times 10 to the 5th kilograms. So then what is the upper limit of the mass? Now, how did we get the masses before? Well, the masses, we took the pounds and divided it by the conversion factor. So now we are going to take 330,000 and divide it by the conversion factor. So 330,000 divided by alpha j is 149,685. I'll write that here. And then to 2 digits, that 9 will cause that to go up. So we're looking at 1.5 times 10 to the 5th. And the lower limit was based on 290,000. Now we have 290,000 divided by alpha j. And that gives us 131,542. To 2 digits would be 1.3 times 10 to the 5th kilograms. So now the mass, if we look at these two here, we can see this is 0.1 and this is 0.1. So the mass with its uncertainty would be 1.4, we'd use the mean value, plus or minus 0.1, these numbers, and that's going to be times 10 to the 5th kilograms. Now, stating the mass with its uncertainty, with the SI prefix, we can't do any metric prefixes with it, if we recall. Can't do the metric prefixes because we're going to combine, so it's going to be the same. And the reason for that would be if we did it with the SI prefix, we'd be converting the 10 to the 5th to 10 to the 3rd, and then we'd have 10 to the 3rd kilograms. It would be combined. So that's why it's the same. Now, what about the upper limit of the force of gravity or the mean of the force of gravity? Well, the mean of force of gravity we already have, which is 1.4 meganewtons. 1.4 meganewtons. Actually, let's leave it in the regular newtons. So that'll be 1.4 times 10 to the 6th newtons. And how did we arrive at that number? Well, we used the mass and multiplied it by g. Well, the mass we have here is this number, the 149,685 number. We're going to multiply that by g. And that 149,685 number came from the 330,000 divided by j. Now, I could just do it over again, or I can hit second enter, and second enter again, and it will bring it back. So I hit enter, there's my answer, and I multiply it by alpha A, which gives me 1,467,913. 1,467,913. And that to 2 digit is, this 6 will cause it to round up. Then we're looking at 1.5 times 10 to the 6th newtons. And the lower limit is based off this unrounded mass for 290,000. Go back to our calculator. And we want the 290 value, so I'm going to hit second enter, second enter, second enter. It brings back the 290,000. And now I'm going to multiply by alpha A, because that's the gravity. And we get 1,128,984. To 2 digits, this becomes 1.3. So 1.3 times 10 to the 6th. Now you'll notice that this is 0.1 and this is 0.1. So the force of gravity with its uncertainty, we start with the mean, 1.4 plus or minus 0.1, that's these, times 10 to the 6th newtons. Or we can say, down below, 1.4 plus or minus 0.1 meganewtons with the SI prefix.